Hey there! Today, we are going to tackle one of the most absolutely stunning designs in the entire poultry world. The double-laced feather pattern. It is a true genetic masterpiece. And, by the end of this, you're going to understand exactly how it all comes together. All right, so first things first, let's look at what we're actually aiming for. Over on the left, you've got your classic single-laced pattern, right? Just a colored center with that one crisp black edge. But look to the right. That's our goal. That's the intricate double-laced pattern. You see all those extra layers? You've got the black outer edge, then a band of color, then, and this is key, a second black inner ring, and finally, the colored center. It's literally like a little bullseye painted on every single feather. So you gotta ask yourself, how on earth does nature create something that complex? It really is a work of art, isn't it? Well, we're about to pop the hood and look at the genetic engine to see exactly how this design gets painted feather by feather. I mean, just listen to this description to really get a feel for it. Wow, it just paints such a vivid picture, doesn't it? This isn't just some simple pattern. We're talking about an effect that transforms the whole bird. And that inlaid with mahogany look, that's exactly what makes this pattern so sought after. And frankly, so tough to get just right. Okay, let's get to the real heart of it, the genetic recipe. And here's the thing you have to understand. There's no single double lacing gene. Not at all. Instead, think of it like a carefully mixed cocktail. It's a recipe that needs 3 very specific genes, all working together in perfect harmony. And believe me, if you miss just one of those ingredients, the whole thing just falls apart. So here are the 3 ingredients. Think of it like you're an artist. Step 1, you need the canvas. That's the E gene. It gives you that nice partridge or brown base color, which is just perfect for showing off a pattern. Step 2, you need the organizer. This is the PG gene, and its job is to kind of sketch out these faint concentric rings. And then for the grand finale, step 3, you bring in the booster. That's the ML gene. It's like the dark ink that goes over the pencil sketch, turning those faint lines into the thick, bold, solid black rings we're looking for. Okay, now this is where things get really fascinating. And honestly, it's a point of confusion for a lot of breeders. You've got these 2 very different looking patterns, single and double lacing, and the huge difference between them often comes down to just flipping a single genetic switch. Just one gene changes everything. And that little genetic switch, it's called the Columbian gene, or CO. The best way to think about this one is as a pigment restrictor. Its whole job is basically to clean house. It comes in and just pushes all the black pigment out from the middle of the feather, shoving it all the way to the absolute outer edge. Get out! So this table really lays it all out perfectly. Look, for double lacing, you need your pattern gene, PG, and your Melanotic booster, ML. But, and this is the whole key, you need no Columbian gene. You have to keep CO out of the mix. That's what lets both the inner and outer black rings show up. Now for single lacing, you use the exact same recipe, PG plus ML, but this time you add the Columbian gene CO, and boom, just like that, it comes in and wipes out that inner ring, leaving you with just that single clean outer edge.
Okay, so you might be thinking, well, if it's just a recipe, how hard can it be, right? Well, this is why breeding is so tricky. Genetics is all about balance. It's not just about having the genes, it's about getting them to express themselves perfectly. And that takes a really keen eye to spot the common flaws that can just wreck the whole look.
So, here are the top 3 things that can go wrong. First up, you get what are called smutty centers. They just look kind of muddy or dirty. That's a classic sign that your black booster gene, ML, is a little too aggressive. It's working overtime. Second, you might see these incomplete inner rings that look more like a horseshoe than a full circle. That's your clue that the organizer gene, PG, probably isn't quite strong enough to finish the job. And finally, there's shafting. That's when the quill of the feather stays light-colored and it just cuts right through the pattern, totally ruining that perfect bullseye effect. All right, so we've looked at the ingredients, we've talked about that all-important genetic switch, and we've covered the common challenges. So now, let's pull all of this together into one clear, simple blueprint that you can actually use. And here it is, the 4 essential rules for double lacing. It's actually pretty straightforward when you lay it out like this. Rule 1, you gotta start with that Partridge Base. That's your canvas. Rule 2, add the P gene to actually create the ring pattern. Rule 3,
Add the ML gene to make those rings nice and dark. And rule number 4, probably the most important one to remember for this specific pattern, you have to avoid the C gene. Keep it out. Otherwise, you're just going to erase that beautiful inner ring you worked so hard to get.
You know, it's definitely a delicate genetic dance, for sure. But when you get it right, the results are just wow. Absolutely worth it. So now that we've laid out the entire genetic blueprint, there's really only one question left to ask, isn't there? What kind of masterpiece are you gonna create?